I'm going to show you how to do a wobble test on an angle valve cylinder, and the anatomy of this cylinder is a little bit different and will require a different type of fixture than you would use on a parallel valve cylinder. I'm using an older cylinder here in the shop because I think I can get the camera in closer and you can visualize this a little better than if it was on an airplane. Obviously, you've taken off the valve springs and the keepers and exposed the end of the exhaust valve. The first thing you're going to need to do is to put in a split gauge, which is just really an extension of the exhaust valve. And in order to do that, I'm going to have to use an Allen wrench and open end wrench, and I'm going to tighten this down pretty tight. One of the few places in this procedure where it's permissible to over tighten is right here, because you do not want the split gauge to be moving at all with relation to the exhaust valve. In other words, you don't want it to have any wobble of its own. After you've put the split gauge onto the end of the exhaust valve, Lycoming says that you should push the valve about a ½ an inch back in toward the cylinder, and this unseats the valve head so that you can get an accurate test of the wobble. Next, I'm going to take a fixture, and this is basically a modification of the fixture that's shown in the service bulletin. I found that when I made the one they had depicted, it didn't quite reach the boss with the set screws and then simultaneously touch the split gauge with the dial indicator gauge. So now, putting this fixture down over the boss, we're going to take a rocker arm shaft, and we're going to use the rocker arm shaft itself as one of the fixation points for this fixture. Now I'm going to line it up with the set screws sort of loose at first. I want to line it up so that the edge of the fixture is relatively parallel to the split gauge. Next, I'm going to insert a centering device that I created that has a cove cut in it, and the radius of this cove is the same as the radius on the split gauge. When I insert this centering device into the fixture and mate it with the split gauge, it ensures that the dial indicator tip will be perfectly perpendicular to the axis of the exhaust valve. Also, while I'm doing this, I'm going to look to the side where you really can't see, and I'm going to ensure that the this surface of the fixture is parallel to the back surface of the split gauge. And now I'm going to tighten these set screws down while maintaining my pressure on the centering device. And once I tighten these down, it should ensure that this fixture will now be fixed in 3 separate places and therefore stabilize it. Now, it doesn't seem to be moving at all. After that, I will put in a dial indicator gauge into that same hole, and I will push it so that it's making contact with the split gauge. Now, tighten, just finger tight, this set screw. I've bored out this hole to be a fairly snug fit, so it's almost superfluous to have this set screw, but just to be sure, you can tighten it by hand, but no more than that. Don't use a tool on that. Once we get this set like we want it, we can use a screwdriver and put a fair amount of pressure onto the valve stem itself, taking care not to touch the split gauge. We can then zero the instrument. Following that, we can come in from the opposite direction with a screwdriver and press pretty firmly and take a reading, and we're getting a reading of about 24.5. I realize there's a parallax here and you can't see the gauge the same way that I do. If the reading is higher than 30, Lycoming thinks that you should probably consider having the valve and valve guide replaced. If it's below 15, then it's either getting tight or already tight, and you should think about reaming the valve. This is pretty much how you do a wobble test on an angle valve cylinder.